questions if you have any. So let's start by looking at a very simple example. With this example is a case where I have an individual making a decision as to whether to make consumption or savings decision and the amount of hours of work. So this is a standard question that we saw in class. So if you happen to go through the bonus question that I gave you guys, this was just a standard model that we saw. Yeah, that's Shane. Shane, please give me your full name. Yeah, I was asking for your full name. I couldn't get it. Okay, then put it there. Thank you. Now, this is the standard model that we had where I have an individual having this utility function. And the good news is we now have the functional form. And this happens to be the budget constraint that's being faced by the individual. And we have to solve the first order condition using the Lagrangian. And this is more or less like an infinite time period.
Excuse me.
Sure.
Sorry, we have a mention. Shin says they remember once they answered a question and you told them to remind you to give them participation marks.
Yeah.
Shin Wang.
Yeah, I just recorded. Thanks. I have it here. Thank you. Yeah, thank you very much.
No worries.
So I'll go ahead and then get it recorded. And again, if Alex happens to be there, let me know your full name, Alex. Now, this is what we had, right, in terms of the budget constraint. Now, for the firm, as we initially pointed out, the firm's decision is technically the same decisions that we saw earlier. And with the firm, we realize that this is the output that it produces. We have Z in front of the capital and the labor. This is the fraction that goes to capital, and this is a fraction that goes to labor. So this is fairly standard. And this is the Z, which is the productivity shock. This E is just an epsilon, it doesn't make a difference, right? So we have this output being produced by the firm. Now, within the same RBC model that we introduced, we also realize the fact that there is a productivity shock that counts with it. So if this is a productivity, which is Z, it follows a certain process. And the process that it follows is basically an AR process. That is to say, the amount of productivity that I have today is determined by the amount of productivity that I have yesterday. Yesterday's productivity affects today's productivity. But this guy here, which is our rho, is basically what we call the persistence. How persistent is yesterday's productivity on today's productivity, right? So this is the setup that we saw. And persistence is very important in our model because as we go along from today to tomorrow, there is a transition process from today that pushes onto tomorrow, and that's being captured by this rule. So keep an eye on this guy. Now, this is the shock process. So this is very, very unique. This is like COVID, right? So this is without COVID, this is like the usual thing that we have. But there is a shock, something that is random, something that we don't expect. It will just randomly hit us. And that's where this guy that we call epsilon comes in. So this completes the AR process. Yesterday affecting today, and this is a total new shock that just hits us without expecting it. So in 2018, for instance, this guy is 0. In 2017, for instance, this guy is gonna be 0. In 2015, it's gonna be 0. But in 2019, because of COVID, it's just gonna come in. And it can be positive or it can be negative. If, for instance, it comes in and affects our productivity negatively, which is the case of this virus, then it will be negative. If, for instance, it comes in and that it affects our productivity in a positive way, like a different way of thinking or a different technology, then we call it a positive shock. So just keep an eye on him. So that's what we call a white noise process. It can be, it has a mean of 0, and technically it can be positive or negative, but at the end of the day, when you find the average of it, it just goes to 0. So that's what we have. And again, this is a very standard assumption as to how the individual thinks. So this is a setup that we saw in class, and this is a setup that I tried solving during that class. Everything is fairly standard now. So I asked you guys to go and try it out using a certain functional form. John, I believe this was the functional form that I gave, or was it different?
I think it was adjacent to that. I don't know if it was exactly the same. I'd have to check.
Sure, no problem. No problem.
Yeah, sorry.
Yeah, it should follow the same process. So just that's fine. Now, one or two things that we have to keep in mind is having gotten to know what these guys here stand for. This is the problem that we have. Now, the question here is, there's a need for us to, redefine a couple of variables in here, as in what is a state variable, what is an exogenous variable, what is an endogenous variable, and all that. So we have to come in and basically open up a couple of things in here. So I have this guy here, which is our standard problem, and I need to ask myself, what are the state variables and what are the endogenous variables? So just keep an eye on this first question. And again, I'll try and then send this file out. Hopefully you guys can read more on it and understand it. Now, what you realize here is within this setup, there are one or two things that are already determined within the model, right? An example is the amount of capital that I have for today. No matter what happens, this capital level is already determined. I don't have any control over it. And that was the example that John gave to class when I asked as to why does KT remains the same regardless of the shock. And the answer was that KT has already been determined, so we can't make a decision as to changing it. But we can make a decision as to changing KT plus 1 because that is the amount of capital we should have in the next period. So keep in mind this guy here, this KT here is already determined, so it's not gonna change. So that's what, when the question asks you what is the state variable, you see here, you can clearly see that these guys are predetermined. This guy KT has been determined already. Another interesting variable that has been determined already as we find ourselves in today's period is ZT minus 1. ZT minus 1 is the shock that we experienced yesterday. So there is nothing new about it. We cannot change anything about it. It's already predetermined. So when you come in here and they ask you for the state variable here, you can also mention that ZT minus 1 has already been determined in period T minus 1. So that is already a state variable. Now, what we technically cannot say has been predetermined are the variables that we need to determine within the model as of today. An example is when you have this setup, you have to tell us how much consumption this individual is interested in having today, which is CT. So it is being determined within the model and it's being determined today. So we call that an endogenous variable. The same thing applies here. When you look at this setup, the individual is also making a decision as to how much to work in terms of the hours of work of today, which is NT. So that is also determined within today. So that is also considered as an endogenous variable. Wage, for instance, it's also being determined today because the market has to come in, get to know supply and demand of the labor market to determine our wage. So wage is also determined today within our model. KT plus 1, as I pointed out earlier, this is more or less like the amount of capital we expect to have tomorrow. So we need to make decisions as of today to determine the capital for tomorrow. So this is also determined in terms of today. So these guys here, all the variables that you tend to see here are being called our endogenous variables, or more or less the variables that are determined within our model. I would like to stop here and see whether you guys have questions. Questions in there, John?
No, sir. No questions as of right now.
Good. So we have this setup ready. We know what variables are determined as of today. We know variables that are determined as of, were determined as of yesterday and all that. Now, the second question is asking us, what is a choice problem? That is to say, what is the individual making in terms of his decision? And this was fairly standard in terms of the problem that we saw because we realized that the individual is going to choose CT, which is the amount of consumption, is going to choose NT, which is the amount of hours of work, He's also going to choose an amount of investment of his capital, which is KT plus 1. So when you come down here, in terms of the individual's problem, these are the things that you have to think about. What about the firm? The firm is fairly standard. In terms of what we saw earlier, the firm is basically choosing the amount of capital and the amount of labor to use in its production. So we also know what the firm's problem is. So let's see how it's going to look like in terms of the problem of the household. So the household chooses these guys here in order to maximize its lifetime budget constraint. So this is a setup. We have this setup here, and this is a decision that it makes in terms of choosing CT, and that's where we differentiated this Lagrangian setup with regards to CT, and we set it to 0. So we saw this in class. Now that we have a functional form, I believe life is much easier. We also said he makes a decision as to the amount of hours of work, and we do that by differentiating this guy here with respect to n. And when you do that, you have this equation. And again, we also said that he also makes a decision as to the amount of hours capital to save in terms of tomorrow, which is KT plus 1. We differentiate the L, the KT plus 1, and we go to this guy. And this is what we call the Euler equation. And you also remember that when you come in here to do this differentiation, there's a need for you to keep in mind the time factor, right? We had to move the t 1 period ahead, because when you move the t 1 period ahead, you get an additional KT plus 1 here, which is also important before you can proceed. So keep an eye on this final equation. So we have the Euler equation, we have the equation that helps us capture the maximization decision in terms of labor, and then the maximization decision in terms of the consumption. Now, the good news here is, as you might have realized, there's a lambda here, there's a lambda here, so I can join these two lambdas together, and as I join these two lambdas together, I can get this new equation, and that's what they call the intratemporal trade-off condition. So keep an eye on that. So this is the intratemporal trade-off decision that we saw. Basically, the decision between the amount of hours of work and the amount of consumption. That's intra. And remember, intra means within the same period, whilst inter means moving from period 1 to period 2. Intra, within the same period, and within the same period basically means that consumption today and the amount of labor today. You're making a decision between these two variables and getting to see where the trade-off lies. In terms of the inter, you are checking between consumption today and consumption tomorrow. It can also be the case that you are checking between the amount of hours of work today and the amount of hours of work tomorrow. So that's where the intertemporal decision-making process also comes in. And there, to get that particular decision, you need to use the Euler equation. And that's where we spend some time trying to capture the implication of the Euler equation. So we saw this guy, we use the Euler equation, we have the intertemporal decision between consumption today and consumption tomorrow. We use the same intertemporal decision to have the amount of wage, amount of hours of work today and the amount of hours of work tomorrow. That's the household's decision. So I'm done with the household. If you guys have questions as to whether the household is going to change the decision and what's not, please let me know. So technically we are done with the household. Now, coming back to the firm, as you guys kept on asking, why is it that I was silent on the firm? Why didn't I capture the firm? And I said it's fairly standard for the firm because you don't need any sophisticated Lagrangian. We just need the basic model that we saw earlier. So the firm is trying to maximize its decision for sure, and it's going to choose the amount of capital, which we know, and it's also going to choose the amount of labor, which we know. So we differentiate this profit function with respect to K, you get this function here. You differentiate this profit function with respect to N, you get this function here. And you can now solve what the interest rate or the price of the capital needs to be in terms of your model. And you can also tell what the price of wage or the wage rate needs to be within the model. So we know what the firm does, which is from this setup. We know what the household does, which is from the setup above. So we can join the two to get the final outcome within an equilibrium setup. So that's just going to be fairly standard. So remember that we saw this equation. Remember this equation, a situation where consumption plus investment equals output. So this is standard. Consumption plus investment equals the total amount of output we have in an economy. This is the wage rate, right? Or this is technically the intratemporal decision-making process between the consumption today and then the amount of hours of work today. So this is also fairly standard from the household decision that we saw. This is the Euler equation that we use in getting the intertemporal decision-making between today and tomorrow in terms of the consumption. You can use the same thing to get that of labor, which is also very important. You need to capture that. Now, this is the rental rate of capital that we just saw here. And remember, it can be changed into Y over K. It's just a very simple math. It will just change. We can change this guy back to K. If you have questions about it, let me know. I can elaborate. In terms of the wage, the same thing. You can change this guy back to K. We have this fairly standard equation. Now, this is the usual Y that we saw. Nothing really sophisticated here. It's just a repetition of what our Y is. Remember this our Y. Remember, this is our Y.
Oh, we have our question.
Sure.
What is R?
Yeah, R is the rental rate of capital, right? So remember, the firm, so remember the firm produces this amount of output, but before it produces this output, it needs to pay for the total cost of labor and the total cost of capital. This is the capital level, but for each capital, it pays R, which is the rental rate of capital. Yeah, that's a good question. If you have questions, let me know. Now, if you happen to be in the room, type experiment as part of our attendance. If you happen to be in the room, type your full name and type experiment, because I'm going to go through the experiment just after this. So just keep an eye on that. Type your full name and type experiment. And keep in mind, we are going to go through the experiment before the close of today discussion. Yeah, so we have this guy here, right? So everything is okay. We solved the problem. We know the shock process. Now, what is interesting here is the dynamics of this model. Now, the question here is, if this is the shock process, right? And I would like to see how the economy changes with the shock process that hits us. Because we happen to have a negative shock, which is more or less like the COVID situation, this guy is going to be negative. And because this guy becomes negative, Z goes down because it's negatively affected. And as Z goes down, there are going to be some implications in our economy, because Z goes down implies that Y goes down. And as Y goes down, there's implication on what our rental rate of capital is, which Ella just asked. There's going to be an implication as to what our wage is. There's going to be further implication as to what our consumption is. And there's going to be an implication as to what the amount of hours of work is. So there are going to be a lot of problems in here. And the issue we have here is we don't necessarily see the problem playing out, because at one point in time, an example here, Z coming down implies that Y comes down, and Y coming down implies that R comes down, or where Z comes down implies that R comes down. The question here is, if you have a situation where R is down or the rental rate of capital is down, it affects this guy here. Now, the question here is, how does it affect C? We don't necessarily see these implications. And at the same time, as you might have realized, there's also going to be an implication as to the decrease in Z on wage. There's going to be an implication. And we don't know necessarily how it's going to play out. So let me show you guys something really quick as to what I'm talking about. So if you happen to have questions, let me know. So I'm just going to take you guys through the sophisticated process of our inability to just pinpoint where the problem will be coming from and where the final outcome will be. So let's take the situation where this shock hits us, right? So there's going to be a decrease in Y because the shock process has come in. We don't have to worry about K as of now because, as I pointed out, K is already predetermined. So anything that happens today, K is not affected. So that's not much of a problem. But you realize that N is determined within this period. So N is going to be affected. So we have to keep an eye as to how N is going to get affected. We have to keep an eye as to how N is going to get affected. So let's take the situation and let's see how N might be affected from this effect. So which one should I start with first? Let me start with the usual ones that we know, which are our usual suspects, and we might just go back and look at the other ones. Let's look at the amount of hours of work, and let's see our inability to just pinpoint what's going on. So when Z goes down, remember there's going to be a wealth effect on the amount of hours of work. So as productivity decreases, the marginal product of labor, which is the wage, decreases, which implies that people will feel poor. And that's very, very standard, because when you go back to this equation, go back to the firm's equation, look at the wage equation. This is my wage equation, right? When Z is down, W is down. And when W is down, this is where we have the individual feeling poor and would like to work more. So that's one effect in terms of the wealth effect of this shock. It makes you feel poorer, and as you feel poorer, you might want to work harder, right? Again, this is not the only effect that might set in. There might also be an intratemporal substitution decision that you are making. And here, the effect might be the opposite of the wealth effect that we saw earlier. And how is that? It's very simple. Imagine a situation where the wage rate is technically down. Within your intratemporal decision making, are you going to consume more compared to you working, or are you going to consume less compared to you working? So that's what we see here. And how does that play out? The answer is very simple. So as the real wage decreases, it decreases the relative price of current leisure with respect to current consumption. So you work less, work time is less, which basically means that you are going to work less. And where do we see this intratemporal decision-making playing out? It's very simple. Go back to this equation and use this guy here, okay? This is one way of looking at what I just finished discussing. This equation might help you, or you might just want to go back up here and look at the intratemporal decision-making and how that affects their decision-making. And lastly, there's going to be an additional effect, which is the intertemporal substitution effect. There's going to be the intertemporal substitution effect, because you are going to make a decision as to whether to work today or to work tomorrow. You find yourself in a situation where the wage rate today is very, very low. You expect the wage rate tomorrow to increase. Now, the question here is, are you going to work more today, or are you going to work more tomorrow? And the implication from this intertemporal decision-making process is very simple. The intuition here is that because the wage happens to be less today, you might want to stop work or lessen the amount of hours of your work and wait till tomorrow where the wage rate comes back high and you start working more. So your wage rate will come down. So there are going to be three effects, and the summation of these three effects will determine the final outcome. Now, the question here is, can we see these three effects playing out in this equation or in these labor equations? Yes. can we make a final decision as to the amount of hours of work is going to increase or decrease? And the answer is no, because we don't necessarily have numbers here to work with. And that was a question that I believe John was asking on Thursday, that I should be specific as to whether this effect is higher than this effect or vice versa. We can't necessarily make those decisions here because we cannot see them. We don't see the numbers. And this is where Dynare comes in to help us. This is where Dynare comes in to help us. So now I'm going to introduce you guys to Dynare and tell you how it comes in to help us and how the implication is going to look like. So we start by just repeating what we saw earlier. First of all, we give the variables that we believe are variables. And these are the variables that we saw back in question 1. So if you go back to question 1, where they ask, what are the exogenous variables and what are the endogenous variables? This is going to help you formulate what to put here within Dynare. So Dynare is made up of, I believe, 4 or 5 settings. The very first one is you define what your variables have. So here, because we already know our variables in terms of our endogenous variables, we will just come in and state them. So we have K, we have C, we have N, we have W, we have R, we have C, and whatnot. So here, we come here, we state these guys here. We also explain what our exogenous variables are, or basically what our exogenous shock is going to be, which is our var exo. So here, we come back here, back to the question that we saw, and we can clearly see what our exogenous shock process was back in question 1, or in terms of our setup. So this was a shock that we saw in terms of the shock process. So that's our var exo. So in terms of my model setup, you might just want to call this guy here EA, basically the shock process. So that's the first setup. And if you have questions about it, just let me know. Now, in terms of the parameters, these are things that don't change in the model. They are not time determined. And how can I see them? You can see them clearly here. And if an example is your beta. Beta is not time determined. You can see that the T is not down, but it's up. Beta is just a constant. This guy here is also just a constant. Neta is also just a constant. So these are constant stuffs. So this is also a constant. So you just go in here and pick up those constant variables. Rho here is also a constant. So you go back there and you pick it up. So when you come back to your Dynare, get to know your setup. An example here is these guys here. So my alpha is a constant. And where do I see alpha? Alpha can be seen here. Remember, this is my alpha. It's just a constant. So I need to come back and place it there. Alpha is a constant. Beta is a constant. Delta is a constant. Rho is a constant. Gamma is a constant. Eta is a constant. So these guys are constants. Yeah, Ella?
Yes. So we make up our own numbers for all of these constants?
Correct. We calibrate. We look at the data. That's a good question. We look at the data and see how, what are the numbers that are very close to our setup. An example here is, so back to Ella's question, an example here is, we believe a firm does this production process, right? So the firm uses capital and uses labor. Now, is it fair enough for me to say that because they use just labor and capital, in the data, the amount of capital that they use is 30% and the amount of labor that they use is 70%? If that's the case, then I just come back to my Dynare and place the alpha to be 0.3. So that implies that 0.3, 30% goes to capital and 70% goes to labor. So that's the 0.3 in there. If you have a different idea as to the amount of capital that goes into production in terms of its percentage, then you can put it here. Ella, is that okay? Yeah.
Sorry, I just had a question. Is this document provided to us, or are we writing this in MATLAB, or how do we follow along here?
It's how Dynare works actually. So I probably have to give it to you guys and make
Okay.
it maybe I think the document that I sent earlier as to how to install Dynare is fairly standard. So I'll make sure I'll send that one as well. The most important thing here is to understand this process. The installation process about Dynare is fairly simple. And
Okay.
just understand one or two things about MATLAB. If you don't understand MATLAB that much, just let me know. If you need help with that, I can help you. Is that okay, John?
Yeah, so we just kind of follow along and understand the intuition.
Exactly. Yeah.
Okay, sounds good. Thank you.
So these are the things that we have. Beta is how patient you are. And I believe Alex was talking about it the other time. And we said beta should be less than 1, most because of how patient how patient an individual is, right? So this is the value of beta. So these are values that we can assign to our parameters, and these are fairly constant. So that's what we call the calibration, right? How consistent the parameters are to data. Question?
Sorry, yes, we have a little question. The TA was supposed to post the videos he made explaining how to use MATLAB, but I don't know where he posted them. Would you happen to know?
I frankly don't.
Okay.
But yeah, I believe YouTube might help a bit. And again, if you guys need a crash course on MATLAB, I can have a section on Thursday for you, which is our last class.
Yeah. And then another person asks, can you explain more about MATLAB?
Sure, that'll be part of the crash course. So if you guys prefer us to have a look at MATLAB, I'll surely do that.
Will any MATLAB/Dynare questions be on the actual exam or just a bonus question?
I'll decide on that.
Okay, so it's still to be decided.
Yeah, sure.
Gotcha. Okay, thank you. No more questions for now.
Good. Now, this is the model, right? So here, within the model setup, this is basically where you put your solution. So if, for instance, you happen to go through the entire process of working the equation out, equation 1, equation 2, capturing equation 1 and equation 2, and you come up with your own solution. This is what you come up with when you do this math, from the first Lagrangian to the first decision-making process and all that. This is what you come up with, right? So this is going to be your final solution. And when you go to Dynare, this is where you put those guys there. An example here is this equation here captures basically 1 over c equals lambda. The first equation that you saw when you have this guy here. This guy, basically this. And that's the equation that you see when you open Dynare. 1 over c to the power gamma equals lambda. You do the same thing for neta, which is the same thing as what we saw here when you do the first order condition for eta. You get it up there as well. Equals w. The first order condition. Yeah, the first order conditions, right? Was that a question, Ella?
Okay, there you go. Yes.
Yeah, you happen to be around as well, type your full name and type experiment. Type your full name and type experiment. So this will be the second part of it. So because the standard time should be around 11:20, I have to end by 11:20. So I'll just quickly explain what the experiment is going to be about. When you guys are in a hurry, you can leave around 11:20. That's fine with me. Those who happen to be around, I'll just take you guys through this entire Dynare process and just explain the experiment quickly and post the videos. So if you have somewhere to go at 11:20, you can leave. If you happen to be around and you have time, you can just stay with us. So for the experiment, it's going to be very simple. What I'm going to do here is I'll send you guys the link and I'll attach the video to it. The video is going to be part of what we have for today. And I'm going to send you guys 2 links. You can use the first link and send the second link to anyone at all, or you can use both links. I don't expect you to spend more than 10 minutes on each link. So it's just going to be very standard. 10 minutes on each link, and you are done with the experiment. But this time around, please make sure you give me your name so that I can get your record straight rather than having to go through asking you guys again what your name is, right? So please make sure you have your name in there. And yeah, so anytime I'll send it by 1 p.m. today, you can have it till Thursday morning. You can get it by till Thursday morning, right? So there's no deadline. The deadline is going to be on Thursday morning. Just make sure you have it done by Thursday morning. If you have further questions, let me know. If you have somewhere to go, you can take a leave now. But just make sure you have the experiment done. John, do you have time? Do you?
Yeah, no, I can stick around. It's another 10 minutes, right?
Sure. So
Yeah.
we have guys here, and as Ella pointed out, these are the equations that we saw in the first order condition. Now we come back here, which is more or less like the initial question, John.
Yes. Experiment 2 is due on Thursday.
Is due anytime from 1 p.m. today till Thursday. So you can have, yeah.
So the absolute latest would be Thursday morning.
For class, yeah.
Okay. And then is the experiment using MATLAB?
No, the same experiment we saw on Thursday. We are going to change the setup.
Okay.
Yeah. So if we are done with the model setup, which is basically the first order conditions and the other equations that we saw, the next line of action is to assign what we believe the steady state values are going to be. The values that we believe are the value we expect to see in the economy in the long run or at the end of the day. Here you can give it any value, but the issue here is if you're not very careful in assigning these values, your approximation or your simulation process becomes a bit rough. You wouldn't see exactly what's going on. So keep an eye on this. So you can give it values, but just be consistent as to what values to assign them.
We have a question. So we can only use Dynare to determine the substitution effect, right?
Yeah, to determine the overall effect, because there's going to be substitution effect and there's going to be income effect. So these two guys are going the opposite way, so we don't see what's going on. So with Dynare, we can clearly see whether the substitution effect is outweighing the income effect or vice versa.
Okay, so we see both of them. We understand the magnitude of both effects.
Yeah, we will understand the magnitude of both effects from the results. So if substitution effect is positive and income effect is negative, and at the end of the day, I see a positive value, then I for sure the substitution effect outweighed the income effect.
Okay, gotcha.
Yeah. So this is the shock process as well. Yeah, so this is a shock process, this the standard deviation and all that. And you finally give the amount of time that you want the simulation process to take. So here I'm giving it maybe 2,100 periods, which is a lot. And for the impulse response function, you can give it 20 in terms of getting to see how the diagram will look like for only 20 periods. You don't want to go through this entire process, which is 2,100, which is pretty much, I mean, it's a long time, but you can use any time at all that you prefer. So this is a setup in terms of understanding it. So again, remember you have the very first setup where you have assigning the variables, you have the calibration process, you have the model, which is fairly standard in terms of what we saw. We have the computation in terms of you giving the initial values of the steady state, and you end up with the further specification of the stochastic process going to look like. So if you are done with this guy, what you can now do here is you come here and type Dynare. After you are done installing Dynare, again, if you have issues installing Dynare, please let me know. I can take you guys through that process as well. I hope that you did. So if you still have issues, just let me know. So this is Dynare. This is how to run Dynare and see the results. So I'm going to click this guy, which is enter. and let's see what the result is going to look like. Now everything is running. So now we have a final outcome, and let's make a sense of this final outcome. How is it going to look like? We start with Z. Remember, Z happens to be our shock process. So we start somewhere here to make our life much easier, to understand what's going on. So when the shock happens initially, the amount of Z that we have in the economy is going to come down, because remember, within your Dynare setup, you had this shock process coming in, but it is negative, right? The shock process here is negative. So when it comes in here, it reduces your Z. So that's how come our Z is down. But remember, it wouldn't go back to the steady state, which is 0. It will take some time to go back to the steady state. And that is because of the persistence in the shock, which is rho. So this is what I tried drawing in our class discussion, that whenever something hits, it takes some time before it goes up back to the steady state. So initially, you might be somewhere here, which is 0, which means there's no shock, everything is normal. But when the shock hits you, you go to minus, and you gradually move back to your steady state. Now, because the shock affects Z, and Z affects your output, we should see an impact on your output right away. So that's how come I now move you guys to this graph. So initially, the output might be somewhere here, which is steady state. There's no difference between what's going on. But because the shock hits you and Z is down, and Z also affect this guy directly, we tend to see that your Y is also down. And the Y will equally take some time to come back to normal, because Z is also taking some time to come back to normal due to the persistence. So I start here. I look at the next variable that is pretty much directly affected with this Z, and I can see the impact. Now, the next question here is, what about C, which is consumption? Remember, with C, we don't know much, because there's income effect, there's substitution effect. We don't know what's happening to the two. But thanks to Dynare, we can clearly see what happens to C. And here, what we see is that the amount of C comes down, which means that there's going to be a negative income effect. There's a negative shock, output is down, income is down. There's no much income, so your consumption comes down. So here, the income effect outweighs the substitution effect in terms of your consumption. In terms of your amount of hours of work, the same thing implies here. Here you can clearly see that the amount of hours of work is equally coming down, because individuals might have experienced a reduction in income, and they expect tomorrow's income to go high. So they are substituting away from today to tomorrow in terms of amount of hours of work. So the amount of hours of work today comes down as the shock hits them, but it will gradually go back to normal. X here is the amount of investment. The same idea, investment will take some time to go back to normal, but as soon as the shock hits you, investment comes down because there's a negative shock. And lastly, in terms of your wage rate and rental rate of capital, the same idea. So this is how Dynare can clearly come in, help us with simulation, and realize whether the income effects will outweigh the substitution effect or vice versa. John, questions in there?
No questions in the chat, but I have a little question. Do we read the graphs from right to left?
What do you mean by right to left? Sorry,
we're discussing like I see. So we start left to right, and the shock is at 0, and so yeah. Oh, okay, I see, gotcha.
So this guy here is a period, right? So here, if you go to Dynare, I'm giving the amount of period to realize here to be 20, right? So when I run it, it ends up at 20 periods in terms of the graph, so period 0 to period 20. But the question here is, on the initial impact, what will be the value of Z? And here I'm seeing it to be negative because it just goes down as the shock hits.
Okay, okay. So the initial position is not the steady state, but it's the state after, immediately following the shock.
Shock hits you,
Okay.
yeah.
Okay, thank you.
Hmm.
Oh, and then do we need to follow the order first Z and then Y?
Yeah, that makes sense. Z is very important in terms of analyzing this because that's where the initial impact comes in, right? So when you go back to this equation, this is where the entire process starts. It starts from epsilon, right? Epsilon hits. The next important variable that is being affected is this guy, right? So that's how come I start explaining from Z just for you to see the true dynamics of it. Is that okay? Sybil? Kristen?
None so far, no.
Okay. Yeah.
Yes, seems okay.
Okay. Sure. Questions, John?
No questions. Well, Anson asks, he still can't see my experiment 1 marks on Canvas after a recheck. Would you mind posting my marks again?
Sure, I'll do that. Yeah.
Okay.
Questions?
Not at the moment, no. Do we have tutorial today? That's a question for me.
I don't know. I should think so, or I think so, right? Yeah, I think you guys should have tutorials today.
Okay, sounds good.
Yeah. So I'll be posting the video to the experiment together with the link, and I'll send it to you guys, and I'll check those that I didn't capture. So let me know if you have questions. If you don't, feel free to join your tutorial section. Okay.
Okay. Thank you very much.
Then. Sure. See you guys.